emulate most Android operating systems, which is perfect for testing different scenarios. The phone is the best thing to test on. If you can get your hands on a couple cheap devices, go to Walmart, pick up a disposable Android phone, and then you can use that as basically a test device for under $100. So plug that in, you'll be able to run your apps. It'll run right from Eclipse. You can debug right there. It'll hit breakpoints and stop. And it's always better to run on phone because you're not getting the simulator, while great, doesn't have the hardware interface. And we have tripped up on not finding bugs and things like that where the phone acted differently. Also, as a note, just because a phone is running, let's say, Jelly Bean, and it's a Samsung, doesn't mean that it's going to work the same way as another Samsung running Jelly Bean. You really have to get down to the provider level too. So is it a T-Mobile, AT&T, Verizon device? And that's where most of our coding is spent, is basically making sure that it's not going to trip up on anyone's particular flavor of Android. And of course, I'm just talking about plain old Android. Amazon has their own flavor for when it goes on the Kindle. There's always devices coming out that run their own flavor. So be very careful about what you're targeting, and make sure you're very explicit if you do have a client about what target devices you're using and what you're going to test on, especially in Android. You can get away with it a little easier in iPhone because everyone expects the 3 devices for it to run on. But Android, you literally have thousands of Android devices out there that are every different flavor combination. So pick some, target them, pick the ones that are the most used, and I'll show you how to get that, and then target those. Okay. So Android is a large subset of Java. So if you know Java, you'll be right at home. There are some things that don't quite flow over, but for the most part, you can do pretty much anything that you can do in Java. It compiles into what's called an APK. This is great in that you can pretty much write a hello world and get it compiled within 5 minutes. There's not some weird compilation process that requires keychain and some signed repository from another third party. You can make your own signature and sign it and upload it in the store in literally under 5 minutes. So it's one of the best things about Android is being able to move quickly and get something out there. Great for proof of concepts. You can start your own project and just play with it and see what happens. So really quick, APKs running their own virtual machines. So this means that apps don't talk to each other a whole lot. They have their own sandbox. They can't go find data of other apps unless you explicitly allow that data movement between the applications. So it's sort of one of those security measures that Google put in place, probably for the better. Of course, if you have multiple applications that you do want to talk to each other, there are ways of doing it. You just have to know about it up front before you put the apps out there. So the other thing you've got to remember is that applications only get the privileges that are required to run. So if you want to do a camera app, just for example, you have to explicitly request the privilege of using the camera. If you don't request that privilege, you're not going to have access to the camera. What this means is that basically users are presented up front what you're going to do in the app. Are you going to access their contacts, add a new contact? Are you going to send email on their behalf, send an SMS, use the camera? All of that has to be notified to the user up front. They can choose to accept that or not. Once you have that privilege, though, it's very, very easy to access that in your code. Google does a good job of putting examples up there on developer.google.com where you can actually download those, run them very, very quickly, and take a picture. The most fundamental part of Android development are activities, and these are views or windows of the application. And activities have their own life cycle, which we're going to talk about. It's very, very, very important. Without understanding this life cycle, you are going to be in pain. It is not going to be pretty. So this is the activity lifecycle. I'm not going to go through every step, but basically what it is that an activity starts, goes through the onCreate event, then onStart event, onResume, then it starts to be running. Once it's running, this is when the app is in the foreground. So the application's running, the user's using it, it's going through your methods that you've created, touch events, everything else. Let's say the user hits the home key and your application goes to the background. This means that it's going to go through this onFreeze, onPause event. So it's going to hang out in this onPause state, which is, onStop event. Once it's in this backgrounded state, it's sort of in limbo. It can either go through this onRestart, onStart, onResume and be back in the foreground, or the operating system may decide to kill it.
Can I cut in just for a second?
Sure.
Can you try to swap your displays? We're seeing your...
Oh, okay. Yeah, sure. How about that?
Much better. Because I figured you were moving your mouse around and didn't know exactly what was going on.
Yep. No, I'm sorry. Thank you for pointing that out, Kyle. So basically, right here, come in and onCreate, your activity's running. Once the user backgrounds it, or even if your application moves an activity in front of the running activity, that particular activity we're interested in goes into this onStop and is in this idle state. If you were to dismiss the activity on top, goes through the onRestart, goes back through this loop. Otherwise, what can happen, and this is the interesting part, the operating system can decide to kill your activity. It's not killing your app, it's killing the activity. So your app is still resident in memory. It still has this state of data that hopefully you've saved in the onStop event. And then let's say the user clicks on the application again. It's going to go through this onCreate event. You want the activity to know that it was dismissed by the operating system and bring the user back to the state it was in. You'll see a lot of apps that don't handle this well in the Play Store, where either it crashes in the background or you start the application again and you're back at the home screen. Well, that wasn't a great user experience. They're not following the activity lifecycle. What it should be doing is storing where it is, and you can do that with bundles and save that state. I'm not going to go into the details, but I just want to bring this big attention to this so that you can create a good user experience. Okay, so we kind of talked about this. Basically, the only time your app is safe is when it's in the foreground, and even then you can kill your own activities or cover up your activities, which send them into different states. And you need to be able to recover and resume from where you left, and you need to save all of that. Your app will crash if you're running on a device and it runs out of memory and the operating system decides to kill your activity, and it doesn't decide to kill the application. Okay. We talked a little bit about this just a few moments ago about asking for permissions, but all of those permissions are requested in the manifest file. This is the key to what your application is going to do. It declares every activity. If you don't declare an activity in here, your app will crash. If you don't declare a permission and you request access to that hardware or that data, your app will not respond. So this is very, very key to making your application run successfully. Quick lesson here from Home Depot. We decided that we would make it easy for people to store when workshops are going to happen. So we have workshops at the store every Saturday, and we decided to put in our mobile application the ability to view those workshops and then add them to the calendar. Users didn't really understand what we were trying to do. All they understood was that the application now requested access to their contacts, to their calendar. So we had a large backlash in terms of reviews and asking us to change it back. So we actually had to do an emergency push to the store and remove that feature. It's kind of interesting side by side. iOS had exactly the same feature, but they are notified as a user when they go and try and do that event. So they try to save that workshop to their calendar, and It notifies the user, hey, Home Depot wants access to your calendar. They go, okay, this makes sense. And it saves, no backlash. In Android, it asks them before they even download the application. So use care, make sure you explain what you're doing, and make sure you're only asking for what you need. Okay, so how do we build stuff? This is the meat of Android development. It's the layout XMLs. And unfortunately, it's also probably the least developed area of the SDK. May jump into Eclipse here in a minute, but basically, it's not as friendly as .NET. It's not as friendly as VB6. It's not as friendly as probably anything you've seen. It's basically a drag and drop, and then you play with the settings until it's what you think it should look like. The issue here is that I understand why Google did this. They have so many devices they're trying to accommodate that there is no one 320 pixel wide view that you should design to. You're designing to every size, and they actually split it up into four different size views, and you can design layouts for each of them, or you can make these things stretchable and fill the parents so that they stretch and modify based on the device they're running on. So you can see here basically what we have is a two area view. You've got a header at the top, and then you have this web view at the bottom. This top view is basically another view that we're inserting, and at the bottom is a web view. And declare it, give it an ID so we can reference it in code. We give it margins to help fill everything up and sit beneath the title bar. It's pretty simple. It's just not the easiest thing to piece together unless you play with it and get to understand how all of this floats around. And all of this is wrapped in this relative layout. So you have to understand XML to get this to work. You also have to understand what each of these little things do. It's also some of them are required, some of them are not. It doesn't always tell you right away which ones are required. So fill parent, wrap content, these are all options that can make the view work differently. So once you have your XML layout, you can reference, so let me just show you right here. So this ID right here, we defined this web view and gave it an Android ID of webview_webview. If you can imagine here, you can actually reference that in code just by basically saying find view by ID. And then it would be our ID webview_webview. So here we're actually asking for an image and then setting an on-click. So I know this is somewhat similar to various programming languages in that you're requesting a reference to something on the view, and then you're giving it an event to handle. So in this case, an on-click, it's opening up this new menu. I just want to dump out some code so you could see that it's actually pretty readable in terms of it's not gobbledygook. It's actually it's very Java. It is Java-esque. It is Java in that you're getting a web response, you're getting an instance of that, you're parsing it, you're getting the alert description, making sure it's not null. If it's not null, go get it, set the text of this object that's on the view, set it to visible. Otherwise, make it invisible. So it's very pretty easy to do some simple tasks of getting views, getting the items on the view, and then setting some data to those views. Where it gets a little more complicated is with tables. You have to use adapters, which are basically data elements that they can attach into tables. And the reason that we have to do this is because, and you can't just populate this massive table, is because in the mobile world, as you probably know, you can't just dump everything into memory and hope that it works. It only populates what's on the current display, plus minus one row, perhaps. And then as you scroll, it dumps off from memory whatever is going off the screen, and then reuses those cells at the bottom and with the new data. So you can't ask it what's in table cell 1. That's going to be different when the user scrolls. What you have to ask it is what's in the adapter at this row. So a little little insight onto that. Okay. We talked a little bit about different size devices and handling that. Eclipse does a great job with that, and Android in general, in that you can set up a directory structure and basically dump in different images or different layouts based on various configurations. So here, what we have are durables, are where you keep your images. So you want a high resolution image, but you may not want to show that on a tiny device, in which case you would put a smaller resolution image in the LDPI, and then let's say you have a tablet version of that image, you put it in the XHDPI. And this is just one of those things you have to know and go and create those directories. It's all documented, but it doesn't come out of the box with those created. You can also do the same thing with operating system level. Everyone in the real world refers to them as jelly bean, ice cream sandwich. Well, in Eclipse, in Android, you have to actually refer to them as their level. So 11, 14, 15, and they get into like the dot. So 2.3.5, maybe 8. So that's how it references that. You can do the same thing with layouts, animations. Everything can be custom fitted into this sizing OS level structure. So let's talk a little bit about how we get our apps distributed and what that means. So play.google.com, that's where everyone goes to download their Android apps. It's great, it's $25, one time, no review process. You can upload in 5 minutes, like I discussed. All you need is some screenshots, a description, sign off on the dotted line that it's not porn or violent, and you're good to go. They will pull your app if people report it, but I've not had any problems. You can see one-star apps that just live out there forever, and they never get pulled. There's no quality control in there, for better or for worse. So you can go and publish something, give yourself a bad reputation, but at the same time, you can also put something out there, and it may be a huge hit. Didn't take 3 weeks to get out there and approved. Maybe you just coded it overnight. You can put it out there right away and just look for some reaction. It's also great if you don't care, in terms of getting it out to your friends, have them do some peer review. You could also email the APK. There's really no security around it, so for better or for worse, it can get out there pretty quick. So I just wanted to give you a cut to some example stats. This is just one of the apps that I have, and it's a little scary, and I'll tell you why. It's scary because it's shown, and this was taken yesterday, 41% of apps in travel and local are still used by people on 2.3.3 to 2.3.7. So if you compare that to iOS, I think it's close to 80% of folks are on some flavor of iOS 6. We have over 40% of our user base still on a version of Android that came out 2+ years ago. So be wary when you say, I'm only going to code for the users with the latest version of Android. It's great. Now you don't have to worry about all the different styles of code that you have to handle, different menu styles, but you're also leaving 40% of your user base behind, and it's actually more than that if you add in the even lower versions, so over 50%. And this is just in travel and local, but you'll see that similar across all. And you can actually go and find the stats across the whole Android user base, but also bear in mind that's usually worldwide stats, so it's a little different. You can get these, if you throw an app up there, you'll find these stats tailored for you. Got some great analytics built in there. I strongly recommend using Google Analytics. It's free, tie it in pretty quickly with Android, and you're good to go. So you can find out what exactly people are running your app on. Okay. We talked a little bit about this. The biggest pain points I see in Android are fragmentation, both hardware and operating system. I should add a third on there, and that's the network carriers meddling with their devices. a little bit about that. Basically, you'll have Verizon throw stuff on there and stop, can't access the Play Store the same way that you do on any other phone. In my opinion, there's too many free phones floating out there.